The lesson topic for this video is graphing polynomials. Now there are going to be 4 different examples in this video, and each one of the examples has something a little bit different than the others. So try to be sure to watch each of the 4 and notice the differences. So first of all, I want to point out that a lot of what we've been talking about in previous examples, and behavior and X-intercepts, will be involved in our graphs. So first of all, let's remind ourselves that end behavior is determined by the degree and the leading coefficient. So since this is a 1, and this is a 1, and this is a 1 on each of those factors, notice that there's no x out here to count as a factor of x. We have a degree of 3, and then we have a leading coefficient right here that is positive. So degree of 3 would mean it behaves like a linear function, and a positive leading coefficient means it will be increasing. So our end behavior is increasing, and I'll just abbreviate that for quickness. So increasing end behavior. The next thing is X-intercepts. And the X-intercepts come from, again, putting 0 in for y. So if I were to put a 0 in for f of x, or y right here, and then use the zero product property to set each of these things equal to 0, each factor set equal to 0, we'll find our X-intercepts. So our X-intercepts are -2, 1, and 3. Notice that since an x is not factored out here, 0 is not an X-intercept, but on a later example you'll notice that we need a 0, and that's going to be something really important that we pay attention to. Alright, the next question is multiplicity of any 0. Multiplicity means a double 0 or a triple 0, etc. And what we're going to notice here is that since this is a 1 and a 1 and a 1, each factor, and therefore each X-intercept, is a single 0. Alright, so there's no multiplicity, there's no double zeros, no triple zeros to pay attention to. And lastly, our Y-intercept. And our Y-intercept we can find by putting a 0 in for x. You may do this by hand by putting a 0 in right here, and right here, and finding out what your Y-intercept is. Or you may put your function into y1 on your graphing calculator and use trace where x is 0. In this case, we get 1.5 for our Y-intercept. Okay, so now we're going to use these pieces of information to help us graph our polynomial. The first thing we're going to do is we're going to put a point where each of our X-intercepts are. So this is the first thing we're going to do here, our X-intercepts. So there's an X-intercept at -2, which is right here. There's also an X-intercept at 1, and there's an X-intercept at 3. So there's our X-intercepts. We know that the graph is going to curve in some way, shape, or form through these points. And those are going to be the only X-intercepts of our graphs. So the next thing we're going to use is our end behavior. Now what that means again is that what will the curve behave like at the ends, or where the arrows are. And since it says it's increasing, it means from left to right, like a linear function would increase from left, down and left, up and right. We need from the farmost right X-intercept right here, we need it to be going in an increasing fashion. Now it's not going to be linear like a straight line, it's going to be some sort of curve going upward, but it is going to be increasing to the right. So we can go ahead and draw like an increasing situation here. And therefore it also, we know from the leftmost X-intercept right here, it's going to have to be decreasing to the, decreasing to the left with the arrow. So something like that. So notice it's kind of like a linear function where you got the lowest to the left and then you got the highest to the right. Now what happens in between? Well, in between there's some curving going on, and we're not going to graph this perfectly by hand, but we're going to get the general idea of the curve. One thing that will help us is our Y-intercept. So we're going to plot the Y-intercept at 1.5 just to help us with what that curve is going to kind of be like. Now this is important too right here. Since there are no double zeros and no triple zeros, what that means is that the curve is going to go straight through this X-intercept. It's going to go straight through this X-intercept, and it's go straight through this X-intercept. You'll understand what I mean by straight through when we look at what happens at a double zero on the next example. Which means that, and again we're doing a rough sketch here, which means that we have to go through this x-intercept and through the y-intercept, come back down through this x-intercept, through the x-axis, and notice that in order to get over to here, we're going to need a curve and come down and go back up through the other x-intercept. So it's going to be something like that. Again, it's a rough sketch, and as you practice these, you're going to get a lot more used to them. So let's try another example. First of all, let's look for our end behavior. We've got a 2 right here and another 2 right here. In the front, this factor of 2 out here does not have an x with it. So we've got 2 factors of x here, 2 factors of x here. We've got degree 4. Because it's degree 4, we know it's going to behave like a quadratic, which means it's going to open up or open down. Since this is positive, it will open up. Our x-intercepts are found again by putting a 0 in for f of x and using the zero product property. If we set 2 equal to 0, it's not going to help us that 2 does not equal 0. If we put x minus 1 squared equals 0, we're going to get an x-intercept of 1. And if we put x minus 4 squared set equal to 0 and solve, we're going to get another x-intercept of 4. Now, notice that we do have what we call multiplicity of both of our zeros. Now remember, a zero is another name for solution or x-intercept. So we're finding that there is multiplicity of our x-intercepts because they're both raised to the second power, right? To the second power. Because of that, they are called double zeros. Okay, both of them. Maybe even put a D by them so that you remember when you're graphing that they are double zeros. All right, we'll come back to that in a minute. And let's find our y-intercept. Again, if we plug a 0 in for x and find our y-intercept, and that is 32. That's obviously not going to be on this coordinate plane that I have to the right, but we can at least get an idea of where that might be. All right, so let's go ahead and plot our x-intercepts. That's where we're going to start, and we have one at 1. So we're going to put a dot at 1, and we have an x-intercept at 4. And the next thing we're going to do is pay attention to our end behavior. They both, from the x-intercepts, and there's only 2 of them, they're both going to be opening up from those points. So we're going to have a curve kind of coming up here, and we're going to have a curve coming up here. We can go ahead and draw that in. Again, kind of like a parabola, but something else is going to happen in here, and it's not just going to come and join here and be a quadratic parabola situation, because that's not what we have. We have a 4th degree polynomial. So what happens? Well, here is our first visit with what happens with multiplicity. Since they're double zeros, what happens at a double zero is that the curve bounces off of that x-intercept. That's what I like to use that term. A double zero bounces. Okay? A double zero. So that means that at this point right here, it's going to bounce kind of like off of the floor, like if it was a ball bouncing off the floor. So it bounces off that x-intercept. And then the other one is an double zero as well at 4, so it's going to bounce off of there. So it bounces off the floor at that point. Well, then there's only one option of what's going to happen here, and that is that the curve is going to join in the middle, like so. Now, one thing I do notice is that since my y-intercept is 32, which is way up there, this curve is actually not drawn perfectly. It's actually much more of a sharp, narrow curve, probably something more like this, so that this was shooting up here more to 32. But not the most important thing right now. Okay, in this example, let's start by finding our end behavior. We've got a negative 3x out here in front. Now, negative 3x means that we have a factor of x right here, and some people miss this. You need to be really careful, but that is an x raised to the first power, and then we have an x plus 2 raised to the second power, and we have an x minus 1 raised to the first power. So we've got 1, 2, 3, 4 factors of an x, which means degree 4. And we know our leading coefficient is negative, so this is going to open down. It behaves like a quadratic, and the leading coefficient is negative, so it opens down. Our x-intercepts. Now, most people don't miss that negative 2 is an x-intercept and positive 1. Negative 2 and positive 1. But something you might miss if you're not careful is that 0 is also an x-intercept, because to find an x-intercept, you put a 0 in for f of x and then use the zero product property. Well, negative 3x set equal to 0, you divide both sides by negative 3, you get 0 for x. So an x-intercept of 0 is absolutely needed here. All right, multiplicity of zeros. We do have multiplicity, yes. And what it is that we have a double 0 at negative 2. So I'm going to put a D right here to remind me I have a double 0 at negative 2. I'm going to put a 0 in for x to find my y-intercept, and when I do that, I'm going to get 0. All right, so let's go ahead and plot our x-intercepts. We've got 1 at 0, 1 at negative 2, and 1 at 1. Our end behavior is that this is going to open down. So from the rightmost x-intercept, it needs to open down, and from the leftmost x-intercept, it needs to open down. Okay, so at a double 0, as you remember from the previous example, at a double 0, the graph will bounce. So at the negative 2 x-intercept, the curve is going to bounce off of negative 2. So instead of bouncing off of the floor, it's kind of bouncing off of the ceiling. So it's going to bounce and come back down like so. Try to make it look curvy and not just like a V. All right, the other two zeros are single zeros, so it's just going to go straight through 0, and then it needs to go straight through positive 1. So we need this to curve around and curve through the 0 x-intercept, and then turn and curve through the 1 x-intercept. So there's our curve for this example. Okay, and in our last example here, I'm afraid I'm going to run out of time, so I went ahead and started this. We have end behavior because of our, let's see here, 3, 4, 5, 6, right? There's a 1 right here. It is going to behave like a quadratic, and since this is negative, it will open down. All right. And then our x-intercepts, again, be careful. We do have 0 as an x-intercept here. So 0 and 2 and 4. So we have those plotted already. Now, multiplicity of any 0. Not only do we have a double 0 at 2, we also have a triple 0 at 0. So there's our double 0 and our triple 0 up there. Well, what happens, and just so you know, a y-intercept of 0 again here. So what happens at a triple 0? Well, remember a double 0 will bounce, so if I've got an x-intercept right here, it's going to bounce off of the x-intercept. Okay, but with a triple 0, if I have a 0 right here, let's say the curve is coming up and hits that x-intercept, it's just going to flatten out, just kind of flatten out right here, and then it's just going to keep going on its way like that. So that's what a triple 0 looks like. And there won't necessarily be arrows at the ends, of course. All right, so let's go ahead and try to graph this one. So at the x-intercept of 0 is a triple 0. So it needs to come up, flatten out here, and then keep going up. So that's what we're going to do. At that point, we know it has to get through this x-intercept, so we've got to have some sort of local maximum here that's going to kind of come up here and then go to this one. It's going to bounce off of that one because that's a double 0. It's going to come up a little bit, come back down, bounce, come back up, and now again it has to just turn and get through this x-intercept here. So, take some practice for sure. Tricky on an iPad also, but I hope you kind of have the idea here.